Alright, well we are here with Unit 10 review, page 1. The first problem is asking us to graph the parent function. My favorite way to graph the parent function is to start with a table. And with all of these graphs, you can always just evaluate one of the x values and plug it into your original equation. In this case, our original is y equals x squared, in order to get the y coordinate of your point. So for here, make sure you put parentheses around the x value before you square it. Negative 2 squared comes out to positive 4. Negative 1 squared will be 1. Then you want to do 0, 0, 1, 1, and 2, 4. And this is the parent function, so these will always be the same point. Your vertex is at 0, 0. Then you've got 1, 1, and 2, 4. Negative 2, 4. Notice our parent function is symmetrical across the line, x equals 0. So that's called our axis of symmetry. And you want to make sure you write that as a line, x equals a number. And it's always going to be the x coordinate of your vertex. And I know my vertex is 0, 0. The vertex in a quadratic function is when you have the function and it's turning at a point. So if you look at this function, it goes here, down, and then automatically turns back up. Well, it's that point where it turns, that's called your vertex. And your vertex is going to be either the very bottom of your graph or the very top of your graph. In this case, it's the very bottom, so that's called the minimum. Does it open up like the U in up, or does it go down? Down would be something like that. Up looks like this. So in this case, our graph opens up. The domain is where does this function hit the x values? Well, your function, your parent function, and all of your quadratic functions, you're going to hit all of these x values positive, because this function continues and continues on forever and ever. It will hit all the x values positive and all the x values negative. So we call that all real numbers. And that will be the case for every function that you graph on this review and on this test. The range is going to change though. You want to look at what y values this function hits. And if you see the y values, they start at 0, 0, and then they continue up. They will never hit any of these negative values. So we call that y is greater than or equal to 0. That's the parent function. Every other graph from here on out will be a variety of the parent function. So this is a really important graph for you to make sure you remember. If you look at the next two problems, it says graph the parent function and the new function, and then compare the new function to the parent. So use words like reflect, or I tell my kids you can use the word flip, shift, stretch, or shrink. We also use the words wide and skinny for those. So I'm okay with those words as well. So what you should notice is that this is the same thing as the regular parent, but it's plus 4. So what that's going to do is it's going to shift this one up 4. Shift up 4. And what we can do is go ahead and graph the parent just like we did in our first problem, and then graph our new function and look to see the change. So that's our parent, 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. Then you take that parent and you add 4. So it's going to shift up 4. So the vertex goes up 4. I'm going to use a black pen for this. So I know my C right here is the y-intercept. Your vertex is 0, 4. And then you can pick another value, let's say 1, and plug it in to see what the y value is. 1 squared plus 4. 1 squared is 1 plus 4 is 5. So your y value is 5 when x is 1. So that point is 1, 5. 1, 5. You can also reflect it across that axis of symmetry to get the other point. And then you can plug in when x is 2 and see what y comes out to be. I know 2 squared is 4. 4 plus 4 is 8. So the y value is 8 when x is 2. So it would be 0.2, 8. So you would go over 2 and up 8 to find your new point and reflect him across the x-axis, axis of symmetry. Notice your parent function was just shifted up 4, which is exactly what this function does. In the comparison spot, I would say y equals x squared plus 4. Shift parent function up 4. Problem number 3, the first thing I noticed is that there is a negative sign in front of the x squared, so I know that's going to flip my graph down. Then I've got a minus 2, so that's going to shift it down 2. So again, they want us to graph the parent function first, 0, 0, 1, 1, and 2, 4. Negative 2, 4. So that's where we'll start. Then I need to graph my new function. We need to start with the vertex, and this is the process we'll be going through this whole review. Start with the axis of symmetry that is the x value of our vertex. So in this case, the axis of symmetry is where x equals the opposite of b. Well, in this case, we don't have b, so he's 0 over 2a. In this case, it's 2 times the negative 1. So your axis of symmetry becomes x equals 0. So you're still reflecting your parabola across x equals 0, that line right there. From there, I can plug x equals 0 back into my original equation in order to find the other value of my vertex. 0 squared is 0, minus 2 is a negative 2. So 0, negative 2 is my vertex. It's also my y-intercept, negative 2. The c value is my y-intercept. So the next thing you want to do in order to solve for another point is pick a value and plug it in. The last problem we did, we picked the value of x is 1. That's always a good place to start. When x is 1 and I plug that in, I get negative parentheses 1 squared minus 2. 1 squared is 1, and then you have that negative sign right there. So it'll be a negative 1 minus 2, which would give me a negative 3. So your point is 1, negative 3, and that would be right there. Then you would want to reflect it across the x-axis and pick another point. We could do x is 2 because we don't have that point yet. So when x is 2, we can solve for what y would be. Negative on the outside of your parentheses, 2 squared minus 2. 2 squared is 4, and it's a negative 4 minus 2 is a negative 6. So your next value is 2, negative 6. Positive 2, negative 6. Right about there. Reflect him across the x equals 0. And you see that our new function did exactly what we thought it was going to do. It flipped down and shifted down 2. So in your comparison, I would put flip down or reflect down and shift down. Well, that is it for page 1 of your Unit 10 review. Stay tuned for page 2.